Chapter 16 Static Electricity.
This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me.
Electric charge. All matters are made up of tiny particles called atoms. An atom consists of three important components, which are electrons, protons, and neutrons. In chemistry, we can determine the number of protons, neutrons, and electrons of every known element from periodic table. For example, a neutral oxygen atom is made up of 8 protons, 8 electrons, and 8 neutrons. So this is the basic structure of an oxygen atom with 8 protons and 8 neutrons. The region that consists of protons and neutrons only is called nucleus. All electrons move around the nucleus in no fixed orbits. So from this structure, you can see that the electrons are orbiting the nucleus. Neutrons do not carry any charge. Protons carry positive charge and electrons carry negative charge. If an atom has the equal number of protons and electrons, it is a neutral atom. Electrons can move from one atom to another. Hence, the number of electrons in an atom can change. Protons and neutrons do not move from one atom to another. Hence, the number of protons and neutrons in an atom is always constant. An atom will be positively charged when it loses electrons because it has more protons than electrons. An atom will be negatively charged when it gains electrons because it has more electrons than protons. When two charges are placed near to each other, both charges will experience a force F known as electric force. Like charges repel each other. Unlike charges attract each other. So, look at this diagram. They are like charges. Therefore, they will repel each other. And this diagram shows unlike charges, they will attract each other. If an object has equal amount of positive and negative charges, it has no net charge. It is known as electrically neutral object. An object will have net positive charge if it lacks negative charges. Similarly, an object will have net negative charges if it has excess of negative charges. When two charged objects are brought together, the objects will experience either attractive or repulsive force. The SI unit for charge is column C. Electrostatic charging and discharging. Materials in which electrons can move freely are known as electrical conductors. Examples are all metals, carbon, and water. Now, the question is, why are metals electrical conductors? The reason is, the outer electrons of the atom are loosely bound and then can move about easily with the metal. This diagram illustrates how electrons can move. Look at the first metal atom. It has one outer electron. So this electron moves from one atom to another atom, continue to move until the atom at the end. So, the first metal atom is losing electrons, hence it becomes positively charged. The last metal atom gains electron, hence it becomes negatively charged. Materials in which electrons cannot move freely are known as electrical insulators. Examples are most nonmetals like rubber, plastic, and glass. The question is, why are most nonmetals electrical insulators? The reason is the electrons of the insulators are firmly bound in the atom and cannot move freely. Electrical charges is either positive charges and negative charges cannot be created or destroyed. The charge of an object will change when it loses or gains electrons. Discharging is the process of neutralizing a charged object. An object is neutralized when there is no net charge. The number of positive charges or protons is equal to the number of negative charges or electrons. Discharging can be divided into two categories. The first one is discharging insulators, and the second is discharging conductors. Insulators can be discharged by heating over a flame. Heat from flame creates charged air particles that neutralize the charged object. Water molecules in air can also remove excess charges from an object. Conductors can be discharged by earthing. In a negatively charged object, earthing provides a path for excess electrons to flow away from the object. In a positively charged object, earthing provides a path for required electrons to flow into the object. Conductors discharging can be done by touching the object with finger or connect it with a wire to the ground. Charging is the process of causing an object to be charged. An object becomes positively charged when the number of electrons is less than the number of protons. An object becomes negatively charged when the number of electrons is more than the number of protons. Charging can also be divided into two categories, which are charging insulators and charging conductors. Insulators can be charged by friction or rubbing. When two insulators are rubbed together, electrons from one insulator are transferred to another insulator. The insulator that loses electrons becomes positively charged. The insulator that gains electrons becomes negatively charged. Examples are plastic and hair, glass and silk. Conductors can be discharged by a process named induction. There are two ways, which are single conductor and double conductors. We'll talk about these two in the next slides. Let's talk about charging single conductor by induction. This is a metal sphere which is neutral. It is placed on an insulating stand. The insulating stand is used to prevent metal sphere from touching the ground and earth. A positively charged insulator is brought near to the neutral metal sphere. Electrons in the metal sphere are attracted towards the insulator. The other end of the metal sphere is lack of electrons, hence it is positively charged. It is then earthed by touching it with finger or connect it to ground with a piece of wire. The positively charged are neutralized as electrons from the earth flow into the metal sphere. After a while, the earthing is removed. Then the positively charged insulator is removed. The metal sphere gains excess electrons and is now negatively charged. Charging two conductors by induction. Two metal spheres, A and B, are in contact with each other. A negatively charged insulator is placed near sphere A. The negative charges in the insulator repel electrons. Resulting electrons accumulate in B. Sphere A loses electrons, hence it becomes positively charged. Sphere B gains electrons, hence it becomes negatively charged. Sphere A and sphere B are separated. The negatively charged insulator is then removed. Sphere A and sphere B now have opposite charges. Electric field is a region where an electric charge experiences an electric force. It is represented using arrow lines, which is known as electric field lines. For positive charges, electric field lines are pointing outwards. For negative charges, electric field lines are pointing inwards. This is positive charge, and you can see that the electric field lines are pointing outwards. This is negative charge, and you can see that the electric field lines are pointing inwards. We know that like charges repel. So let's see how the electric field looks like when two like charges placed near together. So these two are positive charges. The electric field will look like this. And this location is X, the neutral position. For negative charges, when they place near together, the electric field will look like this. And they also have the X point. X is the neutral position. A positive charge experiences zero resultant electric force at this point. We also know that unlike charges attract. So these two unlike charges, when they attract to each other, their electric field will look like this. Electric field between one charge and a plate. So if we have a positive charge and a positive charge plane, the electric field for the positive charge will look like this. And we also have an X point. If we have positive charge and a negative charge plane, the positive charge will attract to the negative plane. So this will be the field. For a negative charge and a negative charge plane, the negative charge will be repelled, and this is the electric field. This is the X position. If a negative charge is placed near a positively charged plane, it will be attracted to the plane, and this is how the electric field looks like. Electric field between two planes. If one negatively charged plane and one positively charged plane are placed near to each other, this is how the electric field looks like. If two positively charged planes are placed near to each other, this is how the electric field looks like. And we have a X position. If two negatively charged planes are placed together, this is how the electric field looks like. And we also have the X position. Now, we will discuss about some hazards of electrostatics. The first hazard is lightning. Ice particles and water droplets in the clouds collide each other and cause the separation of large amounts of positive and negative charges. Surrounding air is ionized and provides pathway for the charges to be discharged as lightning. Flammable materials. Electrostatic discharge creates spark, which can ignite flammable materials and cause fire or explosion to occur. We are not allowed to use handphone in petrol station. Trucks that transport petrol or flammable materials are earthed by hanging a metal chain from the rear to the ground. So this picture shows you how it looks like. Anti-static bags. Some electronic components are sensitive to electrostatic charges and can be damaged by electrostatic discharge. Anti-static bags are used to store those components to protect them from electrostatic charges. Electronic factory workers need to wear anti-static gowns, gloves, and shoes before entering the factory. So this is how anti-static bags looks like to keep electronic components. And this is the anti-static gowns, gloves, and shoes that are worn by factory workers. Now, let's talk about some application of electrostatics. First, we will discuss about the basic principles of photocopiers or laser printers. This is the document to be printed. Below it is the charge drum, which is rotating. Light is shown to the document. When it hits the white area on the document, it is reflected to the charge drum. The area on the charge drum that is hit by light is discharge. A charge image is formed on the drum. Toner powder is sprayed onto the drum. The toner particles are attracted on charged surface. A temporary image is formed on the drum. So the drum will keep rotating and a piece of blank paper is rolled under the drum. The toner particles are transferred to the paper. Heat is applied on the paper. The toner particles are fixed on the paper. Next, let's talk about the basic principle of electrostatic precipitators. Electrostatic precipitators remove smoke and dust particles from exhaust gases before they pass out of emission chimneys to reduce air pollution. So this is the basic structure of electrostatic precipitators. This is a negatively charged metal net. The waste gases containing smoke particles pass through this negatively charged metal net. Then the particles become negatively charged. This is the positively charged metal plate. Negatively charged smoke particles are attracted to the plate. Hence, waste gas without smoke particles pass out to the chimney. Smoke particles are collected after we remove the positively charged metal plate. Another application of electrostatic is electrostatic paint spray. Here is the basic principle. Electrostatic paint spray gives an evenly coated paint and cover hard-to-reach areas. So this is the car body to be painted. And this is the spray nozzle. The droplets of paint are charged by friction when they are sprayed through the nozzle. The car body is grounded. Charged droplets of paint are attracted to the grounded car body. Therefore, the car body is painted with an unevenly coated paint. Heat is applied to fix paint on the car body. Electrostatic fertilizer or pesticide spray used in farms has similar concept with electrostatic paint spray. It sprays fertilizer or pesticide evenly without wastage. This is the spray nozzle. Fertilizer or pesticide droplets are charged when being sprayed through the nozzle. This creates clouds of charged fertilizer or pesticide droplets. The plants are naturally grounded. Therefore, charged fertilizer or pesticide droplets are evenly coated on plants. The benefits of using this type of spray are cost saving, less pollution, and time saving.
That's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write down in the comments. I would love to hear from you. Do you like this video? Please don't forget to like it and share it. Alternatively, you can also enroll this full revision course at Udemy. At Udemy, you can track your learning more effectively. Download my notes in printable PDF form. Take a summative quiz at the end of each chapter. Get your first-hand updated contents from me. Get quicker response from me, and many more. You can get all these benefits at a very affordable price. It is one-time payment, no recurring fees, no hidden costs. This saves you thousands of dollars on expensive tuition fees and revision crash courses. And most importantly, your precious time. Finally, you can do your revision anytime you like, anywhere you prefer. All is available within your fingertips. Check out the description below this video and click on the enrollment link to register the course at discounted price. Alright, until then, see you in the next video. Have a great day ahead.